So now we are going to learn about making layouts for different activities in apps in Android Studio. So here I have defined the layout for the calculator that I will be designing in this app, and this is the Java file. So basically you might be quite familiar with this kind of interface as I have already told you about basic Java. But as you can see here, I am calling the set content view function and I am inflating the r.layer.activity cal, which is basically an XML, that is extensible markup language file. And you must already be well aware of XML file, which involves tags and content between them. In Android, XMLs are used as tags which attributes between the angular brackets in the starting tag, and then there are many tags in between them. So there are two views, like the design view and the text view, in which you can design a layout. In the design view you can see that there are many different kind of controls that you can take from the palette. So basically all you have to do is drag these palette controls and then drop them into the layout wherever appropriate. And this is how you will be defining a layout if you want to do it by the design tab or the design mode, or you can may also define it by the text mode. So for here I have defined a calculator layout by gradually building the layout within, and this is the example of the layout. You may also change the look it will follow on different devices and test the layout on all the devices. Also you can change the orientation mode to see how it will look in different orientation modes. Also you can zoom in so that here I can show you better how it is exactly functioning. So this is the layout that I'm getting. Now here on every element that I click, there is a properties column here in the Android Studio where you can edit its properties. Click on view all properties and this, here you go. So layouts are creating using various controls. So first you have to choose the base layout element. So I have chosen here linear layout element, which specifies the layout in a fixed style. You may also use the relative layout to specify layouts in a relative way. And in the linear layout, I have every layout has an two necessary or required attributes, that is the Android layout width attribute and the Android layout height attribute. This attribute can take three values. First is the match parent, which will inflate the layout's particular width or height to that of the parent, and then there is wrap content, which will only inflate the particular layout element to the space it needs to show all its contents properly. And then there's a fill parent attribute that will fill all the available space it can get from the parent after accommodating other elements. So here I have also specified an Android orientation attribute to be vertical. So basically all the elements in this linear layout will be arranged in a vertical manner, and then I have a linear layout. Here I have specified the Android orientation is horizontal, and this linear layout is holding all the buttons of a row in a calculator. So here the linear layout is horizontal, it is holding all these buttons 7, 8, 9 and the clear button in horizontal, so they are stacked in a horizontal manner. So let's see what happens if we change the orientation to vertical. As you can see, as soon as I change the orientation to vertical, they are aligned vertically, and so you must take care of the orientation that a particular layout is following. And I am defining the layout as a tree. So basically I have to define the layouts, the elements in the layouts along with the layout height and width attribute. Then you may also specify the Android ID attribute, which is used to reference these layouts or manage them from the Java file which will be using them. So you have to use the plus at this at plus id slash, and then you have to specify the id if you are declaring the layout for the first time. If you are dynamically creating these layout elements from the Java file, then you need not do this. But whenever you are declaring the IDs from the XML files or the layout files, you have to use at plus id slash the element name. This will be the unique ID that can be used to locate this particular layout element. So first I have a layout, and then there are many controls. The most common controls you will be using are the text view, which is used as a text label. Then you have the horizontal scroll view, which can be used to scroll horizontally. and the vertical text view. You may also use a button which may also have an Android on-click attributes. As you can see, each layout element here is having attributes here, and then you can also specify many attributes such as Android hint in text view shows this text in light manner. This is especially useful in edit text where you are getting the text from the user, so you can use this Android hint to specify the hint that the edit text should give in fainted manner. Android layout gravity specifies how the positioning will be done in respect to the falling element, and Android gravity also specifies this, but it specifies the layout ordering with respect to the orientation in which the parent layout is specified. Also, Android text is used to put out any text that you want the text view or the edit text to show. The difference in text view, if you specify Android text, it will be displayed as a label, while in edit text, if you specify any Android text, that will be used as the default text which has to be already there in the edit text. Moreover, you can also use the Android style attribute and specify a style of your own which you can define in the style inside the res folder, then inside values folder, and then the style XML, in which you can specify a particular style. So you can basically reuse styles in your layout elements. Then you can also specify layout weight. Now what happens is that if you specify, for example, 4 layouts and each has a layout of weight of 1, so first the 4 layouts will be expanded with the behavior of wrap content, and whatever the available space will be left will be first divided by the sum of these Android layout weights, and then will be assigned proportionally. For example, if there is 40% space left, and if there are 2 elements with one with Android layout weight 1 and Android layout weight 2, so first 40 will be divided by 3, and 2 times that value will be given to the element with Android layout weight 2, and 40 by 3% of that remaining space will be given to the element with Android layout weight 1. You may also use a button with an Android on-click attribute so that you can specify the function to be run from the layout file itself. Remember that any function that you are specifying with the Android on-click attribute of any element, not necessarily a button, should accept a view as a parameter. Also, you may set on-click listeners during runtime or dynamically in the Java files. So let me tell you how this whole layout is made. But before that, you must get through these basic elements. Then you also have many elements which you can experiment with. Then in edit text you have many fields, such as for a plain text password, which will behave accordingly. So for example, if you insert a email edit text field, basically edit text field is used to get input from the user and is derived from the text view element. So whenever you use an email edit text field, so while the user is entering value in that edit text, @ sign or a keyboard specialized for email entering will be shown. Similarly, for the password edit text, all the characters will be hidden by default. Then there are different type of layouts you can specify, and the grid layout is used to specify a table, and you can also use the fragment if you are including fragment, as we'll study later on. A different kind of containers such as list view, all which we'll be studying on, and the scroll view. If your layout is exceeding and it's not limited to the width of and the height of the screen, you can also use a scroll view to enable scrolling, because other than that the views will overflow the screen and the user won't be able to access them. Web view is used to display web content locally or from the internet, but remember, if you are using web view to display online content, make sure you declare internet permission in your Android manifest of your project. Similarly, image view is used to display images, and video view is used to display videos. These are the date pickers and time pickers which are used to take input from the user, and then you have some advanced views that you can use there. So first how I started to make this calculator layout. I started with the main linear layout with the orientation vertical, and then I created 2 main linear layouts in it, one for displaying the answer and one for displaying the control buttons. Both of these are aligned vertically. In the first one, I added an text view for displaying the expression that is currently being entered by the user, and the horizontal text view which contains an answer text view, which can be used to display the answer of the calculation from the calculator. Next we have another linear layout, and remember these two linear layout are specified by the layout height wrap content so that they fill in the existing space, and then I have specified 5 rows in the second linear layout. So, and all these 5 linear layouts are horizontal because they are displaying buttons in a horizontal manner, so they are being placed one after the other in a continuous horizontal axis. So the first linear layout displays the keys 7, 8, 9 and clear, and then another linear layout displays another set of 4 keys, and the last linear layout displays the keys. So basically these keys are the buttons which I have defined, and the last key displays the equal to button. You can see that I have carefully designed all this layout with proper nesting, and I have also specified the Android text of each button, and I have used the Android layout gravity also to specify the gravity, and I have primarily used Android layout weight is equal to 3 so that it is equally divided the space between all the sublinear layouts, as you can see here. Now we must know some terms such as DP, SP and PX. So whenever you are defining dimensions such as width, height, the size of the text in an edit text or text view, you may use these following characteristics: PX responds to pixels, SP and then DP responding to digital pixel. Now PX is a hard-coded value and is different for different devices. So if you are hard-coding anything into PX, then it will be calculated accordingly to the Android device. While DP is independent of the size of the device, and the Android does all the calculations for you. So we can use DP in margins, padding, etc. So basically margin is the space of the element from the parent element, but the border is what it is the distance between the border and the parent element, while padding is the distance between the border of the element and the contents inside it. So it is safer to use margin in most of the cases, which should primarily define in DP, and SP can be used to define the text most of the times. See you in the next tutorial.